Hello everyone, welcome to owasp-Patna's 8th session on web cache deception by Kuldeep Pandya. Kuldeep is a security enthusiast with expertise in web application security. He has been recognized as a Synack Envoy. He has also served as the chapter lead for Null Ahmedabad. Thank you, Kuldeep, for joining in today. Over to you.
Hello everyone, I hope my voice is loud and clear. I shall start my screen sharing. So today's topic that we are going to cover is web cache deception. It is kind of a new topic over the recent few years. It was researched lots of years back, but recently there has been a lot of activity in this specific topic. So before we start, I'd like to share a bit about me. So I'm a full-time bug bounty hunter, as many of you may already know. I mainly hack on Synack and HackerOne. I'm also Synack Envoy and Hero for previous years. I was a former Null Ahmedabad chapter lead, and I am a full-time volunteer as well. I also occasionally do gaming and all, and I'm also the author of Kuldeep.io blog. So what we are going to cover today? So today we are going to cover basically three things. First is the basics, second is the methodology, and case studies. In the basics, we are going to cover all the small topics that we will need to understand the topic and to craft an exploit. The methodology section will focus on discovery and exploit part, and case study will be how I actually use this methodology and found some interesting stuff. To learn the basics, the first that comes is path confusion. It is very simple thing. So what is path confusion? Path confusion occurs when an application routing is misconfigured so that it cannot distinguish between two distinct parts. Just because I said it verbally, it doesn't mean that we understand it. So we have a nice little request response thing here. This is how a normal request looks. You send request to /account/billing, and in the response you can see the card number, CVV, and name on card and everything. So this is how a normal request will look like. But if there is a misconfiguration in routing, you can send a request like /nonexistent.js, and it will still respond with the card details. So why does this happen? So sometimes mostly in PHP based application, there is a wildcard routing, which means that /account/billing will respond in this response only according to your session, obviously. So please note that this cookie is being passed here. But ideally, what should happen in this kind of scenario is non-existent. When you request non-existent.js, it should respond in 404 not found. So to quickly reiterate, this is the normal request. This is the misconfigured request. To reiterate, this is non-existent.js, and it is still responding in card number and CVV and everything. And this is the correctly configured request. So when you request non-existent.js in this billing directory, it responds with 404 not found, which is the correct response that we want. Now web caching. Web caching, it is quite a complicated topic, but the crux is that. Okay, let's understand with an illustration. So whenever you request a PHP script or a similar script, the actual code that is being written on the backend server, it needs to execute, and the response gets sent back to you. So this little gear icon means executing. So for example, whenever you use a request index.php, the front end server pass the index.php to the backend server. The backend server executes the index.php file and retrieves the contents and sends the contents back to the front end server, and the front end server relays the content to the user. So this is how normally this looks like. If there isn't a front end server between visitor and the backend, the request directly goes to the backend server and the contents get sent back to the user. So why web caching is important? Because let's take an example of index.php. Whenever you visit the home page of any website, it basically remains the same unless you are authenticated or there are any other configurations in place. Most of the times, you visit Facebook, the facebook.com page stays the same. You visit Twitter, it stays the same because the home page doesn't need to change that much depending on different users. So these kinds of pages that are mostly static needs to be cached in front-end server so that whenever a user requests, let's see this user 2. So user 2 requests index.php, but this time the response comes directly from user 2 because the response has been cached previously here. What happens in this kind of scenario is that the user gets the response quickly and the backend server doesn't need to waste its resources processing some file that stays mostly static. Okay, I hope you understand this. And whenever you are getting a response that is coming from cache, you will mostly see headers like this: x cache or x cdn cache, etc. There are other headers that also indicate this, but mostly you will see a hit. What does a hit indicate? Hit indicates that the response has been hit in the cache, meaning it is served from the cache. If you see a cache x cache miss miss, it means that the cache has not been served from the meaning the response has not been served from the cache. It has come from the backend server only. Now, cache keys. What does cache keys mean? So whenever let's go to this illustration once again. So this user is requesting index.php, but how will the front end server determine what kind of response will be cached? It can be instead of index.php, it can be something else. For example, account.php. So if the front end server caches account.php, it will not be right because other users will be able to access the account details of user one. So that is not ideal. So how does the front end server determine if a response should be cached or not? So cache keys are a combination of factors that determine if the response will be cached. It is mostly based on URL, user agent, and region, meaning specific users based in, for example, India will receive a response that looks like this. So whenever you request index.php from India region, you will get the contents of index.php that is served from cache. But for example, if you are visiting from Japan, the contents of index.php might be in Japanese, so it might not be ideal to serve Japanese content to Indian users. So that is why region is also very important. And cache key is basically the combination of factors: user agent, the URL, this index.php, and region. It is mostly this, but sometimes it can vary as well depending on the configuration of the front end server. Now, web cache reception. So as I mentioned earlier, let's go to this illustration as well. Web cache reception happens when we get the server to cache a response that is not meant to be cached. As we mentioned earlier, there is a request to index.php, but if we get a response cache that is from account.php, not index.php, and the response is cached, then some other user that is not us, that is not the victim user, will get the response of the account.php, even if most of the times, even if the user is not authenticated. So let's see. The user one sends a request to account.php. The front-end server forwards the request to backend. The backend server processes the request and retrieves the content of account.php. And the contents are served back to users. But in the between, the account.php response has been cached in the front-end server. So whenever some other user requests account.php, the response will be served from cache. Now, normally, this kind of thing doesn't happen at all because most of the time the front end server depends on the extension and the particular configuration of cache keys. So account.php doesn't normally get cached in the front end server, but sometimes we can trick the front end server by using path confusion. So let's take an example real quick. Let's see a response. Kuldeep.io account billing. So this URL returns in results in 200 OK. This is normal. For simplicity's sake, let's call this account.php. So this results in 200 OK. Now if we employ path confusion account.php and this doesn't get cached, meaning cache miss. Miss means it didn't get cached. Now when you visit account.php using path confusion, let's say non-existent.js, we still get 200 OK with the contents of account.php, but this time instead of cache miss, we get a cache hit, meaning the response is served from cache. So this is basically the crux of it, the how it happens. Now let's go back to our PPT. So that is basically web cache deception. When we get the front-end server to cache a response that shouldn't be cached, the response may contain PII, PHI, cookies, session tokens, authentication tokens, etc. And this can be really bad if an unauthenticated user gets access to all of it, because depending on the application, it might land to hefty fines, because if you are in EU, then there are very bad fines if you disclose the user's PHI. Now over to methodology. How do we actually discover this kind of vulnerability? So first thing that you need to do is log into the application. So before you even open the burp suite, you need to log into the application as a normal user. Now once you log in, you have to enumerate all the endpoints that return any sort of sensitive information. So as we mentioned earlier, the account.php, it returns sensitive information. So you need to list all the endpoints that return any sort of sensitive information, and you need to check for path configuration misconfiguration. So let's see how this looks in action. So the application is Kuldeep.io. This is the main application. Let's see in steps. What was our first step? The first step was log into the application. We performed the login. Now second is enumerate all the interesting endpoints. So let's see Kuldeep.io and index.php. Is this interesting? No, because this is just a home page. So you just need to note not interesting, or just don't note this at all. That will be better. The second URL, account.php. Interesting because this returns account details of the current user, so it is interesting. Now let's see Kuldeep.io. Anything, for example, card.php. This is interesting because it returns the current card details of the user. Now next we can see what can we see? Logout.php. This is not interesting. Why is this not interesting? Because it is just a simple logout page. So you can actually remove the not interesting entries and just focus on the interesting ones. Now that we know there are two entries, both of the entries are interesting. It returns some kind of user information. So what do we do next? Now we try path confusion on them. Let's see this in action. Then we try different kind of extensions. Let's see, not this, 404.js. If this results in a cached response, you have to actually visit this URL twice in order to check if the response has been cached or not. So if you see a cache hit, it means that the response has been correctly cached. But most of the times, it might not be that this is easy. So let's see, there is a cache miss. So you try a different extension, 404.css. There is still a cache miss. Let's try a different extension, 404 dot maybe walk 2. This extension is usually used for fonts, I believe. So it might get a cache hit when you visit this URL twice. So now that you know, a walk 2 extension is working, and you can get a cache hit using this URL. So this is how the discovery part goes. You can remove the, and this is a valid finding. Now go to the PPT. So the second part after discovering is how do we exploit the user. To correctly exploit a user, or let's refer to the user as the victim. To correctly exploit the victim, let's open up a different tab. We know this results in a cache hit. So what is the methodology to exploit the victim? First, we send the crafted URL. What is the crafted URL? It is this that we discovered. It is we can call it a crafted URL because this will get the response cached. Now, once the victim visits a URL, the response will be cached. And note that here I have noted that it needs to be a logged in session, because if you visit without login, there might not be any sensitive information in the response. If you log in, there might be session tokens, personal information. So we need a logged in session in order to correctly exploit the victim, and then retrieve the cache response by visiting the same URL. So let's see. So first we send this URL to the victim. Victim has been logged in. Victim opens the URL. Once the victim opens the URL, the response has been cached. Victim will get a cache miss for the first time because when I think this will explain it better. For the first time, when the user receives a response, it will be a cache miss because this is the first time the cache has been served. When the user is getting a cached response, then only there will be a cache hit. So go to the methodology. So when a victim opens the URL, there will be a cache miss on the victim's end, and the response will be cached. And now, as an attacker, we visit the same URL. Now, once we visit the same URL, we will get a cache hit. And from where do we get this cache hit? Because the victim's response has been cached in step 2. So this is how the exploitation goes. But there are a few limitations to this methodology. Not methodology, but this vulnerability itself. We'll see it. So what are the limitations? So as we mentioned earlier, it will not work if the victim isn't authenticated. The victim needs to log in first, because if the victim hasn't logged in, there will not be much information to retrieve from. Now, and the second limitation is it requires only cookies as the authentication mechanism. Why is that? Because cookies are sent automatically by the browser. The browser automatically doesn't send authentication tokens in the header. So cookies are a reliable exploit mechanism in this. The next is it requires precise timing, because Let's see here. In the second step, we have mentioned that once the victim opens the URL, then only the response will be cached. If the victim doesn't open the URL, the response will not be cached, obviously. But in case we visit the URL first, then our response will be cached, and the victim will receive the cached copy. So it will be, oops, it will be similar to this. So in case we mistakenly open the URL that we crafted, then our response will be cached. And then when the victim opens the URL that we sent in the first step, the victim will get a cached copy instead of ourselves. So that is not ideal. We want the response. We want the victim's data, not the victim ours. That is it. And the last limitation is very small window to execute the attack, because sometimes this cached copy only stays for a few seconds, and then the cache gets invalidated. So even if the victim's response has been cached, there might not be enough time for us to retrieve the cached copy. Or when we try to retrieve the cached copy, the response may already be invalidated. So there is a very small window to retrieve the cached copy. Now let's see a case study. So I have documented about this on my blog. You can read it. So in this case study, it was unlike the path confusion thing. This didn't rely on path confusion at all. Instead, as I mentioned in the PPT, there are multiple factors that make the cache keys. So in this particular case study, there was a parameter called request identifier that was in the cache key. So even if we send this crafted URL, it will not get cached, because the caching dependent on the request identifier parameter. So let's see here. So in this particular application, to retrieve static content, the application was sent using a URL like this. It was a GraphQL URL basically, and as you know, GraphQL, it is mostly used for dynamic data, or mostly user data, but sometimes developers want to get static data as well. That is not, I mean, I'm not the one to say this, but that is not the ideal scenario. But most of the cases you will find dynamic data being pulled from GraphQL, but this time the application was pulling static data from the GraphQL. The URL was like this: UI gateway v1 GraphQL. This is the GraphQL endpoint, and then question mark query, and the query was the actual GraphQL query, and there was a request identifier parameter, and it was sent to some random value. So it was like, if it is pulling the home page data, the the request identifier would be like home page static, etc. But it was something random, I believe. Now in the response to this URL, you can see cache hit, x cache hit, x cache hits 1. So what this determines is that the response has been cached, and it is coming from a cache only. Meaning we are not getting the response from backend server; it is coming from front-end server only. And the same URL, same GraphQL endpoint, this UI gateway v1 GraphQL, it was also used for dynamic data like email, first name, roles, meaning all kind of user information. But this time it was sent from HTTP post request instead of a HTTP GET request like this. Instead of this query string, it was sent in a post body. So what I did was I changed this. I changed the request from from post to get, because as we already see, we can send as a query string as well. So I used a query like this. This is basically get to post of the previous request. And in the response, the response was not cached, because as you can see here, there is the request identifier parameter isn't present. In the previous URL, the request identifier was present. So it was a crucial information, because if the request identifier parameter is not present, the server will not cache the response at all. It needs to be present. So to craft the exploit, I just had to add the request identifier. It could be set to anything, exploit me, anything. So this was the final URL that I crafted. So let's go and put this here. So this is a crafted URL. We will send this URL to victim. When the victim opens the URL, the response will be cached, and the cache will be saved in the front end server. Now, when the attacker opens the URL, the response will be served from cache, and the attacker will see a cache hit. Now, even if the attacker is not sending any kind of bearer tokens or cookies, the response still will contain user details of the victim. So this is how, let's see, served from served from cache. So yes, as I was saying, the response will be served from cache to the attacker, even if the attacker has not provided any kind of cookies or authentication information. And I believe this is basically it. If you want more references of further reading, okay, I want to show this particular blog. Mm, mm, Okay, not this one, the previous one. Here you can see multiple tricks and tips for path confusion. You can use this in your methodology. It is a very nice resource, and that sums up the session. If you have any questions, you can ask here. I am available as of now.
Someone has asked, Hardik has asked, do we need to do CSRF to exploit web cache?
Okay, so Hardik, actually, I kind of forgot about web cache poisoning, but I believe we need CSRF, but I'll not. I'll not provide a concrete answer. I, I would be not provide apologies. I might not be able to provide a concrete answer, because it was a long time ago I read about web cache poisoning. So I think your best bet is do a little bit of research on this. Akash is asking, what was authentication method for the GraphQL case study? Cookies or author? Akash, the authentication method for GraphQL case study was cookies only, because if it was an authorization token, we might not be able to perform the attack itself. It has to be cookies only. So what are some of the headers that lets you identify? Actually, there is a whole list of headers, but mostly you'll see something like something that has cache and name, and in the value there is something related to hit or miss, so it will let you identify if the response is coming from cache or not. How can we fix this? So to fix this kind of vulnerability, first you have to fix the routing, uh, because what was that called? Path confusion. So this kind of attack mostly relies on path confusion. Rarely there are cases when it is possible without path confusion. So first thing that you will need to do is fix your routing, because if path confusion isn't possible, then this attack has very little base. And the next thing that you need to do is check your cache keys to figure out what kind of things that are cached, that will be cached. So, for example, if your cache key has a wildcard, for example, cache all the responses that start with slash, let's say, static. So in that kind of configuration, there is a possibility of path traversal that you can use, browser-based path traversal, I believe, that you can use to perform this web cache deception. So first is fix the routing. The second is verify your cache keys. Okay, Rajat is asking if the victim opens a vulnerable URL once, can attacker open it again within a certain time frame, or it's only one time? So Rajat, actually this is kind of this is based on the particular configuration that you have at hand, because sometimes what happens is the front end server is configured so that the response is only served one time. Sometimes the server is configured to serve only in certain time frame, or the response will stay sometimes forever as well in very bad configurations. At code level, there is not much to fix here, because this is not a code level vulnerability. This is a configuration issue, misconfiguration issue. So at code level, you don't need to fix anything. You only need to fix the routing. That can be done, I believe, at code level, because you can set wildcard routing in PHP and Flask and other frameworks and languages. So at code level, you can fix the routing at code level only, I believe. Webs can sometimes block this kind of attack, because they see that okay, multiple extensions are present. And similar, CloudFront, I believe, has not CloudFront. I believe Cloudflare has cache cache deception armor or something like that, but it is still possible, because there was a report that I read on HackerOne that used an obscure file extension that bypassed that deception armor as well. So web can certainly block this kind of attacks, but you will rarely see it. How common are such issues? So I'll say very common, because most of the applications these days employ some kind of caching and front end back end configurations. So this cache reception thing is very common. Even if you check the OpenAI vulnerabilities that people are disclosing, most of them are cache reception issues. So I'll say with modern application, it is more common than older application that didn't rely on front end, back end configurations. So Rajat, I believe there isn't any automated way to find this issue, because you need to understand that certain responses is interesting to you or not, because that response might make sense to you, but the automated bot that you have might not understand it. For example, I shared it in my blog. What is interesting depends on the application's context. For example, if it is a banking application, it might even the address might be sensitive. If it is some kind of other application, for example, let's say if it is a betting application, then what kind of bets you have made might be an interesting endpoint functionality, let's say. So it is up to you and the application what is interesting. A bot might not be able to understand it. The severity of this issue, as in the previous answer, it depends on the context of the application. The severity is mostly dependent on the application's configuration. Sorry, not configuration, context.
Yeah, Kuldeep, I believe that would be pretty much of what we will be asking about questions. Thanks a lot for answering all of the questions, and it's been really helpful. It was certainly a new topic, actually. I'm sure a lot of people must want to know about how does that happen on application level, or how does that misconfiguration go, right? So, yeah,
Correct.
it's helpful.
Yes, and thanks to owasp-patna team to invite me. And it was nice meeting you all as well. The audience has been great, and I really enjoyed answering the questions because most of the times you don't see this many questions. I really
Yeah.
liked it.
So thank you, Kuldeep, for such an incredible session today. Actually, there are a lot of thank you messages in the chat.
No, actually, thanks the audience.
Some people are interested in, knowing whether you will be sharing your PPT, the slides with them. So if there's a
Yes, I'll
possibility, do
definitely
let us
share
know.
I'll definitely share the PPT with you guys, and you guys can share on your social media.
Yeah.
So to all the people in the audience, you can find me on Twitter and Instagram at kuldeep.exe. You can also connect with me on LinkedIn. You can just search Kuldeep Pandya.
That's great. So thank you everyone once again for joining in. It's very good to see all of you, joined in today, and so many people were interested in the session and had so many questions. So that just helps us know that you are liking the session. Have a good day.